morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and you are about to be thunderstruck by the converse of the Pythagorean Theorem. Let's get to it, shall we? All right, here we go. Converse of the Pythagorean Theorem. We have heard it 1,000 times that a squared plus b squared equals c squared. That is the relationship among the two legs of a right triangle, A and B. I should say the lengths of the two legs and the length of a hypotenuse. This is a nice geometric proof of the Pythagorean theorem, where the area of this square plus the area of this square equals the area of the square formed by the side of the hypotenuse. But that's not our focus today. Our focus is the converse of the Pythagorean theorem. That converse says that if I have three sides of a triangle and they fit the relationship a squared plus b squared equals c squared, I know that triangle is a right triangle. Okay? The only thing we have to remember is in a right triangle, the hypotenuse must be the longest side. So right here is a triangle with sides 6, 8, and 5 centimeters right angled. I have to immediately recognize that 8, if it's true, 8 was the longest side, obviously, and that must be substituted for the c in this relationship. So I'm writing a squared plus b squared equals c squared. And the a and the b don't matter. It could be the 6 or the 5 or the 5 or the 6. But what does matter, again, is that the c is the greatest number. So I have 5 squared plus 6 squared. And I'm wondering if that equals 8 squared. So 25 plus 36, is that equal to 64? And the answer is no. This is equal, did I say 56? 36. So that's 61. 61 is not equal to 64. Therefore, our answer is no. This is not a right triangle because it does not satisfy the Pythagorean relationship. So, same idea here. Pythagorean triples are three numbers that satisfy the Pythagorean theorem. And so if those three numbers do that, we call it a Pythagorean triple. It's really the same thing that we just did. We have to show that a squared plus b squared equals c squared. And if it satisfies this, then the three numbers are a Pythagorean triple. When listed like this, we can always assume that the third number listed is the hypotenuse, the longest side. Clearly it is here. So I just need to show that 5 squared plus 12 squared does indeed equal 13 squared. 25 plus 144 does indeed equal 169. And if you do the addition, it is true. Therefore, 5, 12, 13 is indeed a Pythagorean triple. And then we'll do one last thing here. Find k if 9k15 is a Pythagorean triple. So they're telling us it's a Pythagorean triple, which means that a squared plus b squared equals c squared. And this is where it's important that when we list the numbers like this in a set, this is always going to be the hypotenuse, the third one listed. So I can say 9 squared plus k squared is equal to 15 squared. And then I simplify, 81 plus k squared is equal to 225. And then if I subtract 81 from both sides, let's see, I get 4, 144. So k squared is equal to 144. I take the square root. Now normally when I'm solving equations with square roots, I write plus or minus in front of the square root. But since we're talking about the length of a side of a triangle, I know that length has to be positive, so I don't have to worry about the negative result. So I get k is equal to 12 here, and I've solved it. That is it. I hope you enjoyed it. I know you were thunderstruck, so we will go out with a bit more thunderstruck, because with that,